My name is George Enderle. I'm Professor of International Business Ethics in the Mendoza College, and I'm honored to chair this session tonight on climate change. Good evening and welcome to the Berges Lecture Series 2008. We open tonight with a panel discussion on climate change. In the last few years, climate change has moved to the top list of global challenges. For instance, the newest publication of the Human Development Report, published by the United Nations, has the title Fighting Climate Change, Human Solidarity in a Divided World. But climate change has become a fashionable topic in the media, in business, politics, in schools, and even in religious life. And despite the talks, there is much confusion and a great need for thorough information, clarification, and guidance. So we are very fortunate to have three highly qualified speakers with us, all faculty members at Notre Dame. Professor Mark McCready, Professor Gerald Bancock, and Professor Pat Murphy. Before introducing each panelist, I would like to tell you how we thought to organize this panel. Our first speaker, Professor Mark McCready, will address the question, what do we know about climate change? What is the scientific evidence of that? Our second speaker, Professor Gerard Bancock, will inform us about the trading mechanism for greenhouse gas emissions on a voluntary basis, namely the Chicago Climate Exchange. And our third speaker, Professor Pat Murphy, will speak of various climate change initiatives of companies and important ethical principles which can guide us in the debate on climate change. After about 35 minutes, we open the discussion to the floor for discussions from you. May I introduce now first Professor Mark McCready. He is Department Chair of Chemical and Biomolecular Engineering here at Notre Dame and the faculty at Notre Dame since 1984. He has a PhD from the University of Illinois, and his research interests lie in the behavior of multi-phase, namely gases, liquids and solids flows in petroleum pipelines, chemical process equipment, and the environment. Fundamental mechanisms of phase change, for instance, how does water boil, with applications to cooling of high-performance computer processes and methanol fuel cells. He got a number of awards, teaching awards, and is teaching graduate and undergraduate courses in chemical engineering, and particularly a course to seniors on energy and climate, a course which he developed with Professor Patricia Morris and John Bernanke. Thank you very much, Mark, for coming here.
No? All right, let me get a question. I decided since I wasn't from the business school, I wouldn't wear the uniform. What I'd like to talk about, try to get the sound down a little bit here, is things that I think we know almost for certain in 10 minutes and try to give you as much as you can get in 10 minutes about the climate. So as I say, a really brief or quick climate overview. If we look at the Earth system, these bars and arrows tell us what the climate turns out to be. At the start, we have a certain amount of solar radiation coming in. And this amount varies from the sun over some kinds of timescales. And unfortunately, we don't have any long-term data, quantitative data on that. And it would be really nice to know this, but we simply don't have it. Anyway, 342 watts per meter squared comes down. Some of it's reflected off. Again, this is an estimated number. This number is pretty solid. These are estimated numbers. On the scale of these numbers, 1% of uncertainty means degrees of change and uncertainty degrees. So we're trying to get things to less than 1% in a non-laboratory system. So if you have laboratory science, a lot easier. Climate science is not a laboratory science, so 1% is hard. Anyway, everything comes down one way or the other, gets absorbed. And so the greenhouse effect is not really important coming down with the solar radiation. Where it's important is going back out. So the question is, how much is reabsorbed from the Earth's surface and everything going back into space? If there was no atmosphere at all, the Earth's temperature would be frozen at about 0 Fahrenheit. But with an atmosphere where the average temperature is about 59 Fahrenheit, and again, just a couple, 1% mistake in these numbers changes that by a degree or so. So it's very difficult to know all these things for sure. But the effect of greenhouse gases is in this absorbing, how much do we absorb back, going back out? And this loop here of up and down in the lower troposphere is determining the average temperature. And so that's where CO2 and water vapor and methane act to affect the temperature of the Earth. So like I said, it's without an atmosphere of the Earth, of course we wouldn't be here, but if we were here, if there was somebody carrying, it would be 0 Fahrenheit, but with an atmosphere is 59. And this reabsorption of infrared wavelengths by water, carbon dioxide, and methane, that's the greenhouse effect. That makes the Earth habitable. Just to give a quick history lesson, in the past 500 million years, probably most of you don't remember quite back that far. Even the faculty don't know that far back. We've had warm states where there was no ice anywhere on Earth, and cold states where there was considerably more ice than there is now. During all this time, the atmospheric composition is roughly the same as it's been. But of course, humans didn't appear until right up at the very top there. So in some ways, we wouldn't have to adapt all of those things. More recently, from ice core data, and what they can do is they can take drilling machines, go someplace where there's ice has been packing up for hundreds of thousands of years, and drill down. And every year is on the order of a few millimeters. And so from these few millimeters slivers of ice, they can get isotope sampling of oxygen-18, oxygen-16, carbon dioxide, and some other things, and get some information. So what we have here, plotted back 400,000 years, is the nominal temperature in some average sense over Antarctica, where they got the ice, the carbon dioxide levels, and the methane levels. And so there's a lot of correlation between between carbon dioxide and temperature and methane. And so the question of which came first, carbon dioxide going up or temperature going up, is sort of an irrelevant question in the past because that's not really the kind of timescale we're talking about. But anyway, this is the kind of thing. These are called Milankovitch cycles, and they're largely precession and wobbling of the Earth's orbit. On top of it, there's other noise things like solar flares and other kinds of things. It's a fairly regular cycle. The ice ages are like just from about here to here on these cycles. So those are the last previous 3 ice ages. Looking into modern times, here's the last 100 years or so, 140 years. So this is the modern era, characterized by at least the existence of temperature data from thermometers, as opposed to counting tree rings, looking for fossilized coral, or looking for lake bed sediments, which are ways that you can go further back. And we're showing here centigrade degrees versus all of these years. It's an average of the whole Earth atmosphere from available information done by some kind of procedure, which is a little bit elusive because the people who do it don't tell you all the details. But this is the temperature that has been determined as sort of the likely pattern for the Earth surface air temperature. And so what you see here is there's a fair amount of juggling around. The data points are that average for that year. There's a running average smoothing in here, and then these trend lines are drawn. Now, you can look at this plot and kind of sort of see some politics creeping in. This is from the IPCC report from 2007, the most recent Intergovernmental Panel on Climate Change, which is a United Nations-sponsored organization. And in some sense, they've cherry-picked some of the lines to get the highest slopes. Because if you look at this, there's a down, there's an up, and there's another down. So they're not talking about any downs, they're only talking about ups. So you can see that in sort of anything you'll read about, almost from any source, something political will creep in. So it's very difficult to get straight answers from even major journals in climate change on this topic. But anyway, that's the trend. And so in the past 140 years, essentially the time where significant fossil fuel use has been occurring by humans, there's about about 1 degree centigrade, say, approximately, of that during that time of increase. But you're not seeing before this, so we'll get to that. Something that gives us a little bit of more, what is a degree to us? That would be a question that would be a thing to ask. So now this is in Fahrenheit, so I didn't have it in centigrade. But the different color bands are 10 degrees average temperatures for a year. So we're here. So if you go to Indianapolis, you're on the order of 5 degrees Fahrenheit warmer average temperature. About 300 miles gets you 10 degrees. So 1 degree or 2 degrees on here is like south of Plymouth or just before Logansport. So when you think of something like that, the difference is not much. Although you know that's a key difference, don't you? Anybody know why that little bit is difference? The Orville-Redenbacher popcorn line is below US 30. So they don't take the popcorn corn from above US 30. So there is climate does matter. So maybe if it warms up more, they'll have to, Orville's dead. Although he still showed up in commercials, right? Everybody see commercials, he's still in it, but he's really dead. But if he came back to life, maybe they'd move it up a little bit further north, closer to South Bend. In any case, that's an idea. 10 degrees, that's how far it is. The difference, the way it shows up, though, isn't that 10 degrees. Here is the daily temperature of South Bend for some year. I don't know if it's 2004. Okay. And that's an average, sort of the low and average high. What happens is if you creep a couple of degrees, the growing season changes. So what you see from a degree Fahrenheit or 2 degrees Fahrenheit is the growing season will be substantially longer. Because to see if you where this crosses the frost line, wherever the frost line happens to be, it's noisy. But on an average sense, if I slide that down just a little bit, I get 4 or 5 more days, a couple weeks even, from about 2 degrees. So the growing seasons where a great sensitivity is to warming and to cooling. So right on that edge is where you see a big difference. So there's a sort of a fathomable way of thinking of what climate change does on that kind of a scale. Oh, there's the line. Okay. So if you just move this up and down, you change the growing season, and that corresponds to a degree or so of change. Now, the big issue of global warming hasn't been around for very long. Back in the 60s, there was worries of global cooling, and as the various pollution kinds of sources came along and various things happened, that was not necessarily completely unfounded, but it turned out not to be what happened. As recently as 1990, now this is a cartoon drawing, right? It doesn't look like a scientific drawing, but this is the cartoon drawing for what people thought the temperature was. There was the quaint medieval warm period, followed by the sort of brutal little ice age, and then we've kind of moderated to some kind of nice state now. And so if this is what you thought the current temperature was compared to all of this, nothing there would alarm you. You'd say the change, whatever change was occurring, was well within natural kinds of cycles. It was way warmer back in that medieval warm period when they had knights at the round table or whatever was going on then. And it definitely was cooler in the Little Ice Age. So there was nothing alarming about that, if that were the case. But in 2000, based on some new analysis, this was the graph that was produced. And this is the so-called hockey stick. Okay, so nobody ever, it doesn't really look like a hockey stick, does it? Again, we have the gray bars are the year-by-year kinds of things. Everything else is a smooth result. And then the red, chosen, I suppose, for some reason, is the temperature from thermometer era. So before this, you have proxy data. You have tree rings, you have coral growth, you have lake bed sediments. There's some things about fossilized pollen. There's a number of sources. And so people do what they can to reconstruct this. And there's a fair amount of error here. But if you look at the running thing here, you see this rather alarmingly sharp increase. And that was the start of, oh my gosh, this is a big issue. Okay, so this came from this. It was around 2000 by several people published this and then got it into the Intergovernmental Panel from 2000. And that started the current issue as a big issue. Just to show you South Bend, here's South Bend since 1900, and these are the year-by-year averages, and then these are just some running averages. So you can see on a given year, year to year, we have large fluctuations. Mount Pinatubo was a cold year. There was a really hot year after that. So this gives you a sense. So whether that's changing or not, you can decide. But year-to-year fluctuations at a given point are fairly large. The thing that you can say for certain is this increase in CO2. Back in the 1950s, nobody really knew what the carbon dioxide level in the atmosphere was. Nobody really cared about it. But somehow somebody got funded a proposal to build an observatory in Mau out of the Pacific Ocean where you could get some fresh air, so to speak. And they started measuring the carbon dioxide level. And two things were surprising. One, that it was going up inexorably. Another, you could actually see the seasonal temperature changes and algae changes in the Pacific Ocean. So these are very, and other places on Earth and things they've done since then have confirmed that this is, not that this wasn't really any doubt, but it's gone from 315 up to 380 or so now. And then if you get other data from ice core data and other kinds of things, for the last 20,000 years, this is the shape of the CO2. And so it's really gone from about 270 up to 380 during the fossil fuel burning era. And there's really not much doubt that that increases from fossil fuels. So definitive things we can say now, there's no doubt about the CO2 level increasing. It's from fossil fuel burning. Carbon dioxide is a greenhouse gas. It's an absorber of infrared radiation. If you increase the CO2, it causes a forcing on the climate to warm. What's not known with as much as certainly as you'd like, the definitiveness, is how much CO2 leads to how much warming. That is not known. There's models for it, there's things for it, but this is not something that we can say, yes, we know for sure exactly how much it is. But the effect of that, if you add CO2, that you should get warming is not really in question. It's just the amount. Here's a plot from this latest IPCC report. And this just gives you an idea. There's a lot to read on here, but what you want to look at is on the right side, these are things that cause warming. On the left side are things that cause cooling. The error bars tells you how much they admit they don't know. The biggest warming thing is this change in CO2. And then actually methane is a pretty significant increase as well. The biggest cooling thing is changes in the cloud crystal structure, or actually particle size. So aerosols, human-induced aerosols and natural aerosols cause this effect. But anyway, the point is in the aerosols, the error is bigger than the effect. And if you have both of these errors here, the whole cooling effect of aerosols is hypothesized. It's a plausible mechanism, but the quantitative amount is not very well understood. So if you want to put together future predictions for the climate, you actually need to know all of these things. And so to the extent you don't know them, you can't predict the future. So while there's no doubt CO2 is a warming effect, there's no doubt that aerosols and clouds are a cooling effect, predicting the future is really hard. So if we know that increases in CO2 and methane will cause, should cause some forcing that would be warming, the amount is not quantitatively certain. So the predictions for the future of 1 degree, 2 degrees, 3 degrees don't include fundamental cloud physics. The clouds are affected by the aerosols that are from human-induced aerosols and natural aerosols. There's some evidence that they've changed fairly substantially, but we have no data. So predicting the future is pretty hard from that. Changes in ocean currents, again, we don't have anything to compare that against, so we don't know that. And the spatial resolution is pretty limited, so we don't know that. So we can't predict things like, there's claims of predicting storms, that's pretty unlikely. Precipitation would be hard. Anything local would be hard to predict. So it's hard to predict the future, but there isn't much doubt that, again, so quantitatively, these are the model predictions for different scenarios. There's no way that you know that for sure. The forcing is up, but how much is uncertain. It's uncertain. So the issues seem to be, for decision makers, in any case, current use of fossil fuels is unsustainable. At some point, just unsustainable. So there has to be some change in that if we want to be responsible stewards. If you look at the way the history has been going so far, pure market forces may not cause us to behave responsibly. One thing we can say, though, is the timescales for when we would run out of fossil fuels or when a climate crisis would be the point of no return are probably decades, at least. So we're not sitting in the edge of the mountain yet. We have time to make good decisions. But we need to do something. So a path forward would seem to me need to be considerate of both the good of the future society, because we can't ignore the people who are going to come after us, But also it has to have some consideration of the people today, because the death sentence or the imminent thing is not like today. We have time to take a responsible path. Okay.
Thank you, Mark. Our next speaker is Gerald Ben-Cook. Gerald is teaching here in the Mendoza College. He's a native of the Netherlands and resides nearby South Bend in Chesterton, Indiana. Gerald has 24 years of diverse corporate experience with areas of expertise and responsibility that include management, finance, marketing, and operations, both domestic and international. And during his career, he developed and managed major projects and initiatives involving complex business issues, legal transactions, merger acquisitions, and restructuring. From 2002 through 2005, Gerald was President and Chief Operating Officer of the Chicago Climate Exchange, a startup company which became the world's first multinational and multi-sector market for reducing and trading greenhouse gas emissions. And Gerald will tell us more about what he has done in this important work. In that capacity, he designed, implemented, and managed the transition of a unique idea into an actual business and established the firm's infrastructure and trading operations in less than 12 months. Prior to the Chicago Climate Exchange, he served as Senior Vice President of ABN AMRO Incorporation, and he was also Director of International Marketing at Quantum Finance Services. Let's give Gerard a warm welcome.
Thank you very much. Is this on? Can everyone hear me? Okay. Just from a housekeeping perspective, the title in the program is not correct. I'm being labeled as the former CEO of the Chicago Climate Exchange, and I'm the former President and Chief Operating Officer, as you mentioned, so thank you very much. Secondly, since I'm not with the Department of Engineering, I do not have a fancy PowerPoint presentation, so I'm just going to tell you a little bit about our experience over the last 5 years in trying to get something off the ground here in the United States to combat global warming. And all kidding aside, I'm so happy that this presentation started off with a piece of science. I have been in so many meetings with CEOs, CFOs, head of EHS at utilities and the large American corporations, pitching what we wanted to do, only to be bombarded with a repute of the science, basically CEOs denying the science of global warming. And I was always very honest, and I'll be very honest with you. I'm not an expert in global warming. I'm not an expert in that at all. But I always compared it somewhat to Kentucky Fried Chicken in the old days, in early parts of 2000. Kentucky Fried Chicken used partially hydrogenated oil in the frying of their chicken. And that oil contained high levels of trans fat. And trans fat had been argued by the science was responsible or was associated with increased risk for heart disease. But there were a lot of ifs and buts around it. And that basically became my comparison. Whether or not this science is correct, whether or not it is absolutely complete, and you can present it as a fact, I still know, something still tells me that I should not eat Kentucky Fried Chicken for breakfast and lunch and dinner every single day. And that was kind of the message that we wanted to get across to the business community, whether or not this pollution of carbon dioxide contributes directly to global warming and can have this tremendous impact, something should tell you that all this pollution in the end is not going to be very good. Be quite honest with you, that was not the easiest thing to do. So I'd like to take this opportunity and kind of guide you through those early years and what we were up against and what we actually got accomplished. As you may know, the United States was not a part to the Kyoto Treaty. And therefore did not want to be part initially of an effort to reduce carbon dioxide emissions in the United States. I got together with a group of PhDs that had for a number of years done tremendous research and made tremendous efforts towards the design of a cap and trade system. And it was partially based on an existing scheme that the EPA ran on SO2 emissions and NOx, specifically focused at the utilities. And despite the fact that there was no mandate for the business in the United States to do anything about carbon dioxide pollution in the United States, we felt that it warranted an effort to see if we could get a voluntary effort off the ground. We initially obtained a $1 million grant from the Joyce Foundation, that basically helped us complete a feasibility or a design phase that we did with a cross-section of American industry, some 50 companies, some utilities, some automotive companies, some cement companies, what have you. And we basically wanted to see if these companies could help us design a rule book, a set of rules that they could live with, that we could use as a template for a start of an exchange and a system to combat global warming in the United States. The ultimate result was a rule book, and it was a beginning. The focus was very much, let's get something up and running. Let's see if it moves. You can compare it with the Wright brothers. Yeah, let's hope this thing flies. Yeah, they didn't design the Boeing 747 overnight. Yeah, they crashed many times. Ultimately, got something that was able to fly, and ultimately the Boeing 747 came along. So that was kind of the vision that we had. And the underlying idea was we had a strong belief in the capital markets. We believe that capital markets can pretty much solve any environmental problem as long as you find a way to commoditize it. Yeah, so you make pollution a commodity. Once it is a commodity, you can trade it. Once you can trade it, there is a price on it. Once there is a price on it, it becomes a boardroom issue. If there's no price on it, you're speculating. You cannot make it a boardroom issue. Secondly, once there is also a price established on pollution, the capital markets reward those that go the extra mile. So companies that were able to reduce beyond their reduction commitment within the climate exchange, which I will get to in a minute, they were rewarded because they could sell additional reductions to those companies that were unable to reduce their pollution, but still give them an opportunity to participate in a scheme like this. So it rewarded the reducers, and it gave others the ability to participate. So those were the two main objectives. Was it easy? Absolutely not. I mean, we had pretty much everything going against us. First of all, we had no money. We started out with $1 million foundation, $1 million from the Joyce Foundation. That ran out pretty quickly. We looked for private equity. It took us well over 2 years to raise ultimately $45 million. And it was a Jesuit community out of Santa Clara, California, an endowment that was basically there to maintain Catholic cemeteries in the valley there, that gave us bridge financing. Father Smith, I will never forget his name or his letter and his prayers that he gave us together with the check. Was absolutely, I mean, basically he said, you know, you're doing God's work on earth. We've made a killing in the stock market. He didn't say it that way, but he did. So we got some money that we can use for a purpose like this. Ultimately, we got $45 million in private equity, but that was not until we were already well underway. So we had no money. There were issues about the science. There was no mandate in the United States, and there was absolutely no indication that a mandate was forthcoming anytime soon. So we had to bank on a voluntary effort. Can you imagine a voluntary effort? You are the head of EH&S, Environment, Health, and Safety, at a large corporation, and you get the courage to go to your boss or to your CEO and say, I got a great idea. We should join the Chicago Climate Exchange. There's absolutely no reason that tells us that we should do this, okay? But I think we should. And by the way, it's going to cost us $10, $12 million a year, okay? There were not many champions that were willing to do that. So the marketing of this concept was extremely difficult. We had absolutely no political support. The conservatives thought we were tree huggers, while the liberals thought we were capitalists. So either side gave us absolutely no support. I think the only person actually that did, on this day that we started, wrote a proclamation was McCain. And then the last, the groups that we thought would support us, mostly the NGOs, were absolutely against us. They fought us tooth and nail during seminars. Everything we did was criticized, and it led to some really unpleasant presentations during those seminars. They even wrote letters to companies that were on the verge of joining the Chicago Climate Exchange, basically stating that our intentions were not correct and that the company should not join. So all those forces against us just pretty much made us more determined. But there were a couple of things that helped us in actually getting this off the ground. First of all, there were a number of companies that actually wanted to do good. They realized from their own ethics, their own morals, that something had to be done, and they participated on their own. And this included, by the way, one of the leading utilities in the United States. And by the way, I knew from their numbers that this would cost them over the initial first 4 years double-digit millions of dollars. They really got this off the ground on our behalf. Secondly, there was an increased focus on sustainable behavior. There were investor groups coming up that put pressure on the different boards of companies. And there was a trend towards sustainability. The fact that the Dow Jones Sustainability Index came out became very important. So that helped us a little bit. Thirdly, there was some writing on the wall. And the fact that even though it could not be expected within the next 5 or 10 years, those companies with a longer-term view said, you know what, at some point this is going to happen. So why don't we join this effort and become part of the design so we can shape our own future? We can design something that we know is going to work for us. So we don't need to have Washington develop this on their own and reinvent the wheel and come up with something that's not going to work. Fourth, we included something in our rule book that tremendously helped the companies in not only their management, but also their approach towards investors group that were interested in sustainable behavior. And that was verification. We had a third party actually verify as a, let's call it an accountant function, an accountant who audits the financial records of companies. We had a third party audit the emission records of our members, and actually and they came out with an annual report verifying that this company, that this member of the Chicago Climate Exchange had met its obligation, and it was a very detailed report, and it also provided an actual document of emissions inventory for each and every company. As a side note, one of our members, through that effort, recognized that a large portion of their energy needs had not been hedged, and immediately acted on that. So that was an interesting byproduct. The fifth thing that helped us somewhat was the pre-Kyoto trading activity in the European Union, which started at the beginning of 2006. And we recognized that, and we're fortunate enough to license our intellectual property in a joint venture agreement with the leading energy exchange in the UK, the International Petroleum Exchange. They launched our products. It was a much faster way to market for us, and that market developed really well and had an effect on the way we were perceived in the United States. We started off in 2003 with 14 companies, and the exchange now has well over 300 members. Each of these members is required to reduce its emissions over the next years, basically ranging from 1% in the year 2003 to 6% by the end of 2009, which that 6% comes pretty close to the Kyoto targets. And the way it works is very simple. The climate exchange issues allowances that are similar to the company's emissions. So if you're a utility and you pollute 1 million tons a year, and your emission reduction is 1% the first year, we would give you 990,000 allowances for that year. And the emission reduction was 2% for the next year. So for 2004, that company would get 980,000 allowances. At the end of the year, they had to hand over their records. And let's say if they had emitted 1.1 million tons, they only had 990,000 allowances in their account. Well, they had better bought the difference in our market. And since it was a closed system, the system itself achieved its reductions. I'm almost done. So we achieved the objectives. So what does this all mean? And what are the implications for the business? First of all, it has become a very newsworthy item. You cannot open a newspaper anymore these days and it says something about global warming or climate change, which is a far cry from even 5-6 years ago. Secondly, there's a large number of investment funds that now invest in alternative energy, in ways to reduce emissions. And as a result, the alternative energy development over the world has grown tremendously. Let me finish with two things. First, as an example of this innovation, I just found in a local newspaper an article about a Dutch company that invented a way to convert solar energy collected from a 200-yard stretch of asphalt road and a small parking lot to heat a 70-unit, 4-story apartment building in the Netherlands. I mean, that's the type of new ventures that we're seeing these days. Secondly, and then I'm done, if you saw the Financial Times of Thursday, August 21st, it states that companies in the United States face increased climate pressure, and that in the beginning of this year, 75 resolutions filed by socially concerned investors, almost half of those were withdrawn after companies ranging from Continental Airlines to El Paso made immediate commitments to setting targets for reducing greenhouse gases. The other 24 went on to a vote that now secured a shareholder vote of close to 23% on average. And having been on a board of a number of companies, a board starts paying attention to an issue once it reaches about 15 to 20% shareholder support. So with this, thank you for your time, and I'll be willing to address any questions you have. Thanks.
Thank you very much, Gerard. Now, our third speaker is Professor Patrick Murphy. He is C&R Smith co-director of the Institute for Ethical Business Worldwide and professor of marketing. He was also chair of the marketing for over 10 years. He specializes in business and marketing ethics, and he published important books on marketing ethics, which are really pioneering that field in worldwide. He teaches courses on business and marketing ethics at the undergraduate, at the MBA, and at the executive MBA levels at Notre Dame, as well as courses in corporate citizenship and sustainability. He published many articles and wrote books, and so in the last publication in 2007 was, for that he received the Charles Later Memorial Best Paper Award from the Journal of Macro Marketing. Thank you, Pat, for coming.
I guess I've got to do this one more time here. This great new system we have here. I think I got to put my password in here. Sorry, but there should be a PowerPoint here with only. George, where's the up here from the beginning? Okay. So as George said, I'm a professor of marketing, so we'll talk both about marketing and ethical implications. I'm not an expert and certainly not technically trained like Mark, but I'd like to start with just what I'd call a brief history lesson. There's not too many people that study this issue from the 70s onward, but looking at some of the environmental issues, pollution of all types, there were things going on in the 60s like the Cuyahoga River in Cleveland area actually caught fire at one point in time in the late 60s and led to some of the environmental legislation. Population problems, not just growth in population, but the affluence population. This is one of the issues, problems with the United States, is the affluence and energy consumption. Those of you in this room that are my age or near probably remember the first gas crisis in the 1970s. There were these long lines at gas pumps. Some of you probably read about it or saw it in your history books. One of the things Professor Ennerle and I talked about is this notion of sustainability, which has kind of supplanted the term environmental issues. And the definition is up here. It came out in 1987 with this Brundtland Commission. It wasn't my definition, certainly. But meeting the needs of the present without compromising the ability of future generations. And we'll kind of get back to that. If we fast forward from the 70s and the 90s to this century, if you will, or post-21st century, that, as Mark pointed out, the climate change issue is one that really wasn't around until, it probably was around, but we weren't paying much attention to it for the last 3 to 5 years. Global warming, as well as the loss of habitat and species. We've probably all seen the news reports with the polar bears and melting ice caps and rainforest problems. So those are just a few of the kind of overall environmental issues. Next, if we look at what was the marketing response, one of the things that George was going to mention during the introduction was I actually did my dissertation on environmental problems and marketing over 30 years ago. It has a long title, so I'll spare you that. But, and dissertations, plural, there were a number of dissertations in the marketing field looking at environmental problems in marketing. A good friend of mine, professor at the University of Michigan, who I may or may not call next Monday, was another individual who did his dissertation in this area. Also, something you've probably seen in Sears or other appliance stores is these energy labels on appliances. They've actually been around since I think about 1978, trying to give people information to make environmentally sound decisions, at least with respect to energy. And then the field of marketing adopted what we call green marketing, where they talked about the recycled content of products. One of the things studying this since the 70s, there really wasn't much of a market up until the last few years for a lot of these green products. And as marketers have a penchant to do, what did they do? They became involved with what's called greenwashing, which is not a very flattering term, but basically said that they've overstated the benefits to the environment of their products. One of my favorites was that our plastic trash bags will decompose faster than our competitors. And if you know anything about plastic trash bags, none of them decompose very much. There was just an article in a special issue of the Ethical Corporation magazine on climate change last November, and one of the subjects was making green products gleam, G-L-E-A-M. In other words, trying to sell these green products. They have a hybrid car here, but the first principle was avoiding greenwashing. So I think the fact that we need more transparency and less greenwashing is pretty obvious. In the 21st century, we have new products that didn't exist that long ago, such as the energy-efficient light bulbs, and I'm pleased that I haven't changed my gas/electric light for about 6 months, and I used to change it every month. I think they're supposed to last about 10 times as long. They're more expensive. It was good to see the local Martins promoting them this week. And hybrid automobiles, certainly not a long-term solution, but these are products that didn't even exist 5 years ago. So the other thing that's going on in the marketing field, I think more so in the UK than in the United States, are these carbon labels that talk about the carbon footprint. And just in January's issue of the Ethical Corporation, the Carbon Trust in the UK has these little labels that tell how many grams of CO2. At least I think, Mark, they're on the right track. At least they're trying to measure CO2. But two of the major retailers in the UK, Boots and Walkers, have a number of these labels on their products. Just this month, Coca-Cola, Cadbury, Schweppes, and Kimberly-Clark say they're going to label, I'm sure not all of their products, but at least some of their products with these carbon labels. Any of you that are Timberland shoe wearers or shopped for shoes recently, Timberland in the United States has recently put on their shoe boxes a score from 1 to 10 of how much the carbon footprint is of their products. So I think that there's some examples of this carbon labels, but like anything else, it has benefits and costs. What are the benefits of these labels? That they give information, consumers information about carbon that they didn't have before. It's certainly some information. They position their brand positively, like Prius automobile, Toyota has gotten a lot of mileage out of that, and also focuses corporate attention on climate. And I'd just like to read you a short paragraph that Business Week had a story about climate change and these carbon labels, and it said PepsiCo's Walker unit spent 2 months researching the carbon label on its popular cheese and onion flavored potato chips. It learned that farmers were using energy to hydrate potatoes because they were paid per ton, and wet potatoes weigh more. Walker's cut the energy used in making the chips by a third by changing how it buys potatoes. So that it's things so fundamental as that I think will eventually help move us in the right direction. The costs of these labels, or much of the marketing activity with regard to climate change, is the effect on consumer behavior is still questionable, and this ethical corporation says why green is a hard sell. And one number like this CO2 number, the number on the Timberland boxes, really can't accurately convey the carbon footprint, so that we need to get more sophisticated. But another cost is really educating consumers on what their carbon footprint, what the products that they buy have. And I'm afraid in this election year we're going to hear a lot of rhetoric about that, but not so much of useful information. Just to conclude, or the last slide here, to try to tie it into some ethical issues that are important. The precautionary principle is one that is followed much more in Europe. As Gerard said, many of these things, the Europeans are far ahead of the U.S. And I'll just read you the definition. Anybody that wants it, I'm happy to give it to you after the fact, but I didn't want to clutter up the PowerPoint slide. When an activity raises the threat of harm to human health or the environment, precautionary measures should be taken, even if some cause and effect relationships have not been fully established scientifically. So it's erring on the side that Mark McCready was saying, that taking precautions and doing some of the things in the climate exchanges and other things. Secondly, the power responsibility equilibrium is sort of as its name implies. It says that the largest, most powerful organizations, corporations like General Electric, the energy companies, others, have more responsibility in this area, and if they fail to shoulder the responsibility, there will be, at least hypothetically, legislation, maybe more, in fact, public opinion moving against them. But basically saying the most powerful economic organizations have the most responsibility. The balance notion, as my students, we've talked a little bit about the ethic of the means, trying to find this middle ground, and Professor Enderle and our colleague Lee Tavis did an article in the late 90s on what they called the balanced concept of the firm, that we look at the triple bottom line, and environmental climate issues are things that we take into consideration, as well as economic and social ones. And the future generations as stakeholders. Up until, I think, fairly recently, this was somewhat controversial, but I think more and more people are saying, what kind of world do we want to leave for our children, our grandchildren, if we don't start thinking about it now? What is our ethical responsibility? And this really ties into the stewardship notion, which we discussed today with respect to Catholic social teaching. But I think, as Mark put it, responsible stewardship should be something that we as business executives and business faculty members and business executives pay more attention to in the future. That we do have some special ethical duties regarding the area of climate as part of the whole environmental picture. There's a lot more that could be said, but you've sat here patiently, so I think we'll move to the questions and answers. Thank you for your attention.
Thank you very much, Pat. You see, these are important questions and a lot of information and interesting things. Unfortunately, we do not have much time, and we will have to stop in a few minutes. But there is time for 2 questions. Who would like to raise the first? Yes.
A quick question for Science Speaker Jared Hancock. Sir, hi. You were talking a bit about the purchasing of credits between firms within the organization, within the exchange. In some ways, is it possible, say firm A manages to reduce emissions or whatever they pollute by the standard, they continue to free up more credits in your zero sum that you have as you reduce. Does that not allow firm B to continue to stay in the market and pollute? And what issues are you using to combat that as a loophole?
So if I understand your question correctly, you're saying that, I got one good steward, and this basically allows a dirty polluter to continue his or her habits, right? Actually, that was a criticism that we were confronted with many times, especially by the NGOs. And as a matter of fact, the argument was used, why should you even allow somebody to pay somebody else to clean up their own mess? My response to that was pretty direct. I asked the people that asked me that question, I said, well, do you have household garbage? What do you do with that? You pay somebody else to clean it up for you. All kidding aside, the system, and again, I think that is what the working of the capital markets provide us with. By having those that have the ability to clean up, by the way of incentivizing them to go beyond their reduction commitment, you give those that cannot or are not willing to, or it's not financially feasible to do so, you give them still an opportunity to be socially responsible. And that was really the premise. And so everyone can be winners. It really doesn't matter who cleans up as long as it gets cleaned up. That was the argument. I hope that answered your question. Okay.
Thank you. Yes, please.
You mentioned that your members have grown to over 300 in the last 5 years. I'm just a little curious of whether you're seeing more support on a regional basis. And the reason I ask that is just because if you look at the EPA's NOx rule that came out 3 or 4 years ago, you tended to have more political support in regions like the Northeast as opposed to the Midwest. Are you seeing similar trends for carbon?
Not within the exchange. While there is now an initiative that has been in the works for a very long time, and as a matter of fact, the exchange is creating a sub-market for that. But the northeastern states came together and actually are starting to do something on a mandatory basis. But in our membership, we did not see much of a regionalization of our members. They came from all over and from Canada and Mexico as well.
Unfortunately, we have to conclude our session. It was a very exciting session. I would like to thank all three speakers for their presentation. Thank you.
Stay after.